Hello dear friends, today we are going to discuss about the electrodynamics. What do you mean by electrodynamics? Electrodynamics is the branch of physics which deals with rapidly changing electric and magnetic fields. Next we are moving to the history of electromagnetic theory. As you know, electricity and magnetism were considered to be two separate forces. For a main effect resulting from these interactions are: first one, electric charges attract or repel one another with a force inversely proportional to the square of the distance between them. Unlike charges attract, like ones repel. Magnetic poles attract or repel one another in a manner similar to positive and negative charges and always exist as pairs. Every north pole is yoked to a south pole. An electric current inside a wire creates a corresponding circumferential magnetic field outside the wire. Its direction depends on the direction of the current in the wire. A current is induced in a loop of wire when it is moved toward or away from a magnetic field, or a magnet is moved towards or away from it. The direction of current depends on that of the movement. What do you mean by electromotive force? It is also called EMF. In electromagnetism and electronics, electromotive force is the electrical action produced by a non-electrical source. Devices provide an EMF by converting other forms of energy into electrical energy, such as batteries. Next, discussing about the electromagnetic induction. Electromagnetic or magnetic induction is the production of an electromotive force, that means voltage, across an electrical conductor in a changing magnetic field. Michael Faraday is generally credited with the discovery of induction in 1831, and James Clerk Maxwell mathematically described it as Faraday's law of induction. Lenz's law describes the direction of the induced field. Faraday's law was later generalized to become the Maxwell's Faraday equations, one of the four Maxwell equations in his theory of electromagnetism. Electromagnetic induction has found many applications, including electrical components such as inductors and transformers, and devices such as electric motors and generators. Next, we are discussing about the Faraday's experiment. You can see in this figure Faraday's experiment showing inductions between coils of wire. The liquid battery, right side, we can see the right side, provides a current that flows through a small coil A, creating a magnetic field. When the coils are stationary, no current is induced. But when the small coil is moved in or out of the coil B, the magnetic flux through the large coil changes, inducing a current which is detected by the galvanometer. Next, discussing about the theory of Faraday's law of induction. Electromagnetic induction was discovered by Michael Faraday, published in 1831. Faraday's law of induction makes use of the magnetic flux phi b through a region of space enclosed by a wire loop. The magnetic flux is defined by the surface integral phi b equal to surface integral b dot d capital A, where dA is an element of the surface enclosed by the wire loop. B is the magnetic field. The dot product of B dot A corresponds to an infinitesimal amount of magnetic flux. In more visual terms, the magnetic flux through the wire loop is proportional to the number of magnetic flux lines that pass through the loop. When the flux through the surface changes, Faraday's law of induction says that the wire loop acquires an electromotive force, that means EMF. The most widespread version of this law states that the induced electromotive force in any closed circuit is equal to the rate of change of the magnetic flux enclosed by the circuit, equal to minus d phi b divided by dt. The direction of the electromotive force is given by Lenz's law, which states that an induced current will flow in the direction that will opposes the change which produces it. So we are seeing the negative sign here. These are some introduction points about electrodynamics. Thank you.